else that we are planning to do or already done was the achieving the thermal conductivity of the composites, all those test specimens that has been described previously, under different temperature and different humidities. This is also actually one of the main advantages of using a transient method, that you can record thermal conductivity under different temperature and different relative humidities. And these are the details of the testing sample that we use for the second objective, and range of temperature and relative humidity that we have used. And you can see the testing setup, that we have a humidity chamber. We placed the MTPS sensor in there with our sample, and recorded our temperature like that. But the only important thing to focus on this at this point, when you are varying the temperature and the humidity, is to achieve thermal equilibrium or isothermal condition, not only for your sample, but for the whole setup. Yes, some of the results that were still under writing and developing, how the thermal conductivity varied with the temperature, um, and also how the addition of aerogel particle has impact on the thermal conductivity. As you can see, you probably would find lots of similar details in the literature, which we kind of consider is as a validation of a result, that the thermal conductivity was varying linearly with the temperature, which has been reported by several researchers in the literature. As you can also see the R square, which is quite linear, and also how the relative humidity altered the thermal conductivity. We have observed that changing the relative humidity from 30 to 75% linearly or does not significantly alter thermal conductivity, but when we increase the relative humidity from 75 to 100%, so in that range, it was substantial increase in the thermal conductivity.